Okay, welcome back. In this video, we're just going to see what we did last week and then build on top of that. So last week we just finished off setting up both controllers to be third person, top down. So just be aware, I by mistake just overwrote the script here. So if I were you and you're watching these videos, at the point where we do the top down controller, I would duplicate the script and then reuse it so that you have two separate ones, because you don't need all of this kind of control when you're doing a side scroller. So what I want to do today is just like, how do I use this for a 2D game? So let's go about doing that. So I'm going to save this scene. I'm going to call this 2D top down. Okay, and we're going to start by we'll start with the bolt one and move on to the code. So I'm going to hide the camera of the code. And the camera will now need to, we really could do it two different ways. We could do it just like a physical, like a literal top-down game like this, or we could do it from the side view. That is up to you what you want to do. But because this is a 3D game, I'm probably going to want to use nav mesh and stuff. So I'm going to leave the characters where they are. I'm going to rotate the camera to be 90 degrees so that it's looking directly down on the character, like that. Probably going to reposition it, so I'll leave it for now as it is. So you can do it from the side view. It makes no difference. If you are actually using sprites and you're doing the 2D render and all that stuff, you're probably going to want to do it the other way. Okay, so now let's go and duplicate the script. So I'm just going to move the slider so I can see the names. So the player controller bolt, I'm going to select it. I'm going to go Control D to duplicate it, and I'm just going to call this one TD for top-down 2D. We're going to go to our player and just replace the macro we're using with the top-down 2D one. There we go. Now we're ready to start going. You'll see everything still works because we haven't changed anything really. We just renamed the script and repositioned the camera. So you can see everything is still working. But there's a few things I want to go through in the graph. For the case of this game, if I'm making something like The Binding of Isaac or I'm making Enter the Gungeon, I will not be required to have any of this. So he's not going to do any jumping or any of that stuff. So I'm removing the jump. We're also not going to set the player's rotation in the direction. We're going to be using code. We're going to use sprites for that. So the sprites are going to do that kind of thing for us. And then let me just move this across. Makes a little more sense if we put it there. And I think that's it. So we removed the rotation, so we no longer need that, and we're still feeding in the update. We're going to change this animator when the time comes to have a 2D animator, to have an animator with 2D sprite sheets on it. So now if I move it, he no longer rotates, but everything is still working. He's still moving around like he should. Okay, so I'm going to go and create a new folder here. I'm going to call this sprites because that's what I want to put it. And I went to itch.io, if I remember correctly, and I downloaded this little sprite sheet, which just has a top-down character moving down, left, up, and right. And first thing we need to do, the major difference between the 2D and the 3D controller really is just the way the asset you're using, or the visual assets that you're going to be using. So when we get these images, we are going to need to install a particular software for us to be able to edit the sprite sheets. I'll show you now. You'll get the error, and then I'll show you how you do it. So first things first, the texture type here needs to be Sprite 2D and UI, so that it knows that it's going to be a sprite sheet, and it can be used on the UI or as a 2D element. Because this is pixel art, I don't want it to be blurred the way it currently is now. So I'm going to go to my filter mode and change it to point, so that it gets rid of the blurriness, because this is pixel art, so you should be able to actually see the pixel. And I'm also just going to change the input size to what it says it should be down here. So it's going to be 256. I'm going to hit apply. Notice how the image is crisp now, and there's an alpha now. Now the image has transparency. Now if I try to go here and change it to multiple, because now I want to take this one single image and make multiple images from it. And I click Sprite Editor, I click Apply. Now it says no Sprite Editor window registered. Please download the 2D Sprite package from your package manager. So that's what we're going to do. We're going to go Window, Package Manager. And for those of you out there, if you're having weird issues like I do, when it says all packages, this isn't all the packages. Even if I click refresh, it might be the speed of my internet that's causing this, but I find that if you kind of just switch through go to like in project, go to my assets, and then just kind of switch back again, then they all kind of show up. It seems to be a refresh issue, but again, it could just be my internet, so you might not struggle from this. So just kind of cycle through these and come back to all packages when you're done. Okay, so we're looking for 2D Sprite. We're going to install that. Again, depending on your internet speed, shouldn't take too long really. It's just a little package that allows us to edit images essentially edit images in Unity. It used to be standardly, by default, it used to be installed, but now they've trying to make the file sizes of your project smaller by just, at least that's what I assume, by making these packages installable after the fact. Okay, so once it's done, you'll see that it says remove at the bottom. If there are updates, you'll get an update button at the bottom here. So periodically go and check on that to see what versions have been updated. So if I hit Sprite Editor now, there we go. There is my sprite sheet. This is a really nicely laid out one. This one is properly laid out. But let's talk about ways that you can slice and dice this image. If you have a very complicated one that isn't built on a grid like this, you might need to go in and start by clicking the slice button at the top here and go automatic and click slice. And it looks like nothing has happened, but if you click on each of these images, you'll see that it actually has gone through, automatically found where the pixels are, and sliced the images accordingly. Now, but if you have one that is a perfect grid like mine, you can also go to where it says slice and choose grid by cell size if you know the pixel size for each of these little images. But if you're not sure, just go grid by cell count. And you can say, okay, there's 4 characters across and 4 down, and then hit slice, and automatically notice the size of the sheets. They're now perfectly, you can fit 4 of these down and 4 of these across. So that is what that essentially does. So start with automatic if you have a more complicated one. But if all else fails, you might need to go in here and left click and drag and create your own little blocks. You can go and create as many as you need for it to work. So that is how this works. Okay, so I'm going to go through and just rename these so they make sense. So this one is going to be forward 01. I'm going to select this. Actually, it's not forward, it's down. What am I saying? Down 01. The lockdown is breaking my brain. 2. And this might take a little bit of time depending on how big your sprite sheet is. But if you're willing to just kind of go through and look at the images and decide which ones belong where, then you're more than welcome to skip this step. But I like to be able to find things really quickly, so I like to spend a little bit of time making sure that my filing, my naming and all of that is correct, so that I don't have to spend too much time going through every single image and hoping that I find the right one. Probably should write a script that renames the stuff for me, but nah, not yet. I don't do enough 2D at the moment to do something like it. And then this is the last one. We're going to go right 01. We're going to go 02. We're almost done. 03 and 04. I'll try to share the link for the sprite if I can find it again. I'm sorry I'm not crediting the artist who did this. I will try to find who the artist that did this is. Once you're done here, make sure you apply in the top right. It now saves it. If we go out of here, you'll see that we now have a little drop down and you can see all our little characters as separate little images. Okay, so what's the next step? I'm going to go and remove my character, my physical model. So I'm going to go in there and delete my physical model. I'm going to right click on my player bolt, add a 2D sprite. Let's rename this sprite to player sprite. And I'm going to probably scale it up to about, let's see, 5, 5, 5. And you won't see any image because currently the sprite is empty. So I'm just going to randomly grab any of these. Makes no difference. It makes no difference. They are going to be removed. Now, because the camera is looking up, I'm just going to rotate this like that. just going to move it up a fraction. Like I said, this is not the best way to do it, but this is a good way to do it if you already have the 3D controller set up and running. So all I need to do now is remove any excess stuff like the sphere collider that we used for the ground check. And I need to go into my capsule collider and set it up. So now the capsule collider is in a weird place. So I need to go down to my Y position, push that down. And I'm going to also go into wireframe so I can just kind of see where the collider is. And then I'm going to go back to shaded, and I'm just going to scale the radius up a little bit. I'm also going to make the height. I don't think we need the height to be much, to be completely honest. I think I'm going to make the height like a meter. And I'm going to just make this so it almost covers her pigtails. And then I'm going to move it in the Z position so it encompasses the little sprite. There we go. Let's just see what it looks like from a 3D view. Whoops, sorry. Okay, so that looks good. I'm just going to push this above the ground just to make sure that it isn't hitting the ground. Okay, so that's it. So if we test this now, everything should still work. No animations will work, but at least the character will be moving around with. Okay, so I'm having a little bit of jittering because the camera needs a little bit more speed up. So I'm going to make it like 10. Make it a little bit smoother. Could be a little bit better than that. Let's try 20. It might become too much. No, that's not too bad. Okay, so let's make it 15 then. Okay, so now that the character's moving around, we need to actually physically go and set up the animations and create an animator. So in here, I'm just going to right click, create animator, and let's just call this 2D animator. I'm going to select my player sprite, and I'm going to add an animator, and I'm going to assign the new animator to the controller section of the animator. Just so that it now has one and it's good to go, it's ready to go. Now we need to go and create animations. How do we do that? We go to Window, Animation, and open up the animation window. I'm just going to dock it down here. And this is good for everything. So if you've ever worked in Blender, Maya, Max, it makes no difference. Houdini, this is essentially a way to keyframe stuff. Anything in Unity that can be keyframed you can keyframe materials, changing colors, lights flickering, that sort of stuff. So here we're going to go and grab all our little animations here and create animations for the character running up, down, left, and right. Make sure you have your character selected and click the create button in the animator. We'll go out of here, go into my animations. I'm going to create a new folder here called sprites. This first one we're going to call is idle down. And because this character doesn't really have a lot of frames for idle animation, I'm just going to drag this single frame and we're going to use that as our idle animation. I'm going to turn the lighting off here for now just so we can. So this single frame is going to be my idle down, and we're going to do the same thing for left, right, and top. So I'm going to create a new one, call this idle left. Grab the first frame of the left animation. If you just scrub through, you'll see that it actually updates in the viewport. Okay, and then the next one, create a new one called idle right. Grab the right animation and drag it in there. And then the last one is our up. So I'm going to create a new one. So idle up. Grab the up frame and we're good to go. We've done all 4 idle animations. Now we need to go here and click create new clip, and we're going to call this, let's just say, walk down. We're going to now select the first frame in the walk down, hold down shift and select the last one, drag it into the timeline, and we need to drag the first one to the end, at the end, because we need the first and the last frame to be the same in order for the animation to loop. So if I play it now, it's extremely fast. So I just want to go and set this up. So for now, I'm just going to grab all of the keyframes by doing a rectangular selection in the timeline. And you'll see that if I zoom in, you'll see you've got this little kind of rectangle here and rectangle there. If you hover over either one of those, you get arrows going left and right. That's kind of like how you're going to scale your keyframes. So I'm going to set this to be 30 frames long. That's not seconds, that is frames, just so that everybody's aware. So this is 30 frames long. Let's play this through and see if this looks better. Yeah, I'm good with that. So I'm now going to do the same thing for all the other animations. I'm going to make them all 30 frames long and then tweak them if I need to. So I'm going to go and create a new one called walk right, I think we're doing. It's actually, now it was left, but now we're doing right. So let's grab the right animations, drag them into the timeline, grab the first one, drag it into the end, select all of them, and let's make them 30 frames long, and let's just play it and test it. Okay, so that one is done. Let's create the next one. We're going to go walk left, select the left animation images, drag them in. What's nice about this is you don't need to do it with a sprite sheet. So if you go and model and render a character in Unity, in Blender, for example, and you set the camera to be orthographic, frame it correctly, you could render an image sequence of a walk cycle, bring those image sequences into Unity and do the exact same thing. And you'll get the same result as doing what I'm doing now. Okay, there we go. So last one, let's go walk up. So I'm going to grab the walk up animation piece. They're only 4 frames long, so it doesn't take too much time to do this. Okay, there we go. We're good. We have done all the appropriate and required animations. I'm going to double click on my animator. The moment I do that, notice how the animations, all of the animations are in here. Every single one. So we're going to delete this, all of those. We're going to start with an empty single state. Now, a lot of like other online tutorials use, if I press the W key, play the walking up animation. If I press the D key, play the walking right animation. I've always, I come from a blendtree background or a blend space, depending on whether it's Unity or Unreal. So I prefer to set it up because then all I have to concern myself with are 2 variables. The X movement and the Y movement. That's it. So I want to make sure that I don't need to deal with those 2 variables. So I'm going to make a blend tree for all of our states. I'm going to select this one. Let's just call this locomotion or movement, up to you. I'm going to right click and say create blend tree in state and then double click on that. And we're going to change this from a 1-dimensional blend tree. Like earlier on we created a 1-dimensional one. This time we're going to create a 2D freeform Cartesian. And I need 2 variables here. So I'm going to double click on the blend one here, and that's going to be my X position. I'm going to create a new float, and this one's going to be my, let's call it Y position because of the graph. X, Y, and make sure in the actual 2D freeform Cartesian, the first one will be X, the second one will be Y, and while we're just going to go and add 4 motion fields to start. You can also add it here if you right click on the state. And we're going to do one for, we're going to go up, left, we're going to go up, down, right, left. So this one's going to be our idle up. And up is going to be in our Y position. Now I'm going to show you something. This, again, it seems a little weird, but we're going to do it this way because it does work, and it's a lot less work in the long run to maintain. So this one's going to be 0.1. This one is going to be idle down, and this one's going to be minus 0.1. The next one is going to be idle right, and this one is going to be on the X, 0.1, and then this last one here is going to be my idle left, and it's going to be minus 0.1. So now you can see we've got this little diamond shape or cross shape or graph, however you want to look at it, and if we move this little thing across, we go up, down, right, left. So you can see that it is working as I go through the different states. So we need to add 4 more of these. I'm going to right click, add motion, add motion, add motion, add motion. And now we're going to do the movement one. So the first one, again, we're going to do walking up. And this time that's going to be 1 in the Y. This one's going to be walking down, and that's going to be minus 1 in the Y. The next one is going to be walk right. That is going to be 1 in the X. And the last one is going to be walk left, and that's going to be minus 1. Now if we look again at the graph over here, press play. This time we have some animation. You can see that as I move, while I'm in the idle situation here, I think I might have a weird animation going. Oh, I have a walking animation over there. That makes sense. There we go, it's working. So I just need to replace this walking down with an idle down. Now we can try that again. Idle in different directions, walk in different directions. So we are pretty much ready to go with this. Now we just need to do the code for the animation movement. I'm going to close my animation window here. I'm done with that. I'm going to go to my flow graph. I'm going to go to my player here, and we are going to be updating this basically in here. Okay, so if we don't have any jump, we no longer need this gravity, so we can also delete that. Push this up here. Remember, we normalize the values here. We've got all our usual code that we need. It's all where it's supposed to be. This is where we stop the player movement after the input, which is what we wanted. And then while this is moving, we're going to create two new graph variables. Let's just call the one Animator X. It's going to be a float, and the next one is going to be Animator Y. These are the two variables we're going to feed into the animator. So we're going to go up here and just do that really quickly at the top here. Okay, so we're getting an error, which means the animator is missing. So we're going to go to Object. We're going to assign the animator. I'm going to search in the scene for my player sprite, because that's where the animator is assigned. And we can delete all of these, the absolutes. We don't need that anymore. We can also delete this. We no longer need that. And for the X, so we're going to replace that with an X, and we're going to grab the animator X variable from our graph, plug that into the value, and then we're just going to basically duplicate these two, plug that in as the reference for where the animator is, change this one to Y, and change this variable here to Y. Okay, so now we're using two new variables we created. They're currently going to do nothing, so the animator isn't going to do bugger all, basically, to be completely honest. So don't worry too much about this red node. Bolt only updates every time on runtime. It updates the actual nodes, so you don't have to worry about whether there's an error. Only if there's an error after the game runs, then you have an issue. So what I mean by that is it's currently red, so if I start the game just to clear that out so that it can show me that the animator is working correctly. There we go. Okay, so like I said, this is my own way of doing things. I find that I like using it this way, and I like doing it this way, so it just makes sense to me. So this is why I do it this way. So when we're moving the player here, we are going to hold Alt and drag both the animator X and the animator Y, because we're going to set those values. And what are we setting those values to? The player input is the X, and the player input Y is the Y. I know you're probably thinking, if you're going to do this, why don't you just use the player input for the animator? I'm going to show you that now, why I do it this way. Update animator variables. There we go. Update the animator variables. Okay, so once we're updating these and we release the button, we're going to take these values. So we're going to take the animator X. We're going to duplicate these two again, because we need to set these two one more time. Can I stop selecting it weird? There we go. And then we're going to grab them as get variables. So we're going to get this one, we're going to get this one, and then we're going to divide. Duplicate this one more time. We're going to divide both values by a float, and this is going to be 10. So when the input is at 1, and we stored that value, I'm going to divide that by 10 so I can get 0.1, which is going to give me the result for the idle animation. So I know this is a little unorthodox, but I find that, again, I kind of code from an artist's perspective, so I always kind of look at what is the best way to get something that's going to be easy for an artist to kind of set up. And I find that this works really nicely and it makes sense as opposed to like saying, oh, press. The other one is can also be a little tedious. I feel that the other way can be very time consuming to go into every direction and changing every state. This one has no state changes. You're just inputting values. So take input and divide by 10 to get idle value for Animator. That is what we're doing here. Again, we can try this out and test this out. It should all be working right now. Actually, it will not, and I'll show you why it's not going to work right now. Actually, well, let me explain it. So if I leave it as it is, we can test it. The walking is going to work just fine. The idle is going to be funky. So there we go. Walk left, walk right, walk up, walk down. And notice how it goes to 0. The reason for that is we're always firing this value. So which means we're taking this value of 1, dividing it by 10, then taking 0.1, dividing it by 10, taking that and dividing it by 10 till the point we end up with 0. So that's not what we want. And we also don't want this velocity to be firing every damn frame. We're calculating standing still character's velocity every single frame. So we're gonna fix that while we add it. Select these two. Move them across a little bit, and I'm just going to add a branch between this. We're going to do a check. We're going to check for something before we do anything. We're going to do a branch, and I'm going to plug that into there. Might as well just plug it in like this just to neaten things up a little bit. Makes no difference. There we go. And this branch is going to be checking to see if the player has velocity. So we're going to go and grab the velocity from the player. So we're going to type in rigid body dot velocity get. So we're going to get the player velocity, and if it is not equal, we're going to plug in there. So if it's not equal to 0, that means the character is moving. Then we're going to go in here and fire off all of this. But as you probably have noticed here, the moment it fires in through, it's going to 0 all of that out, which means this should technically fire off once. So I'm going to put a group around this as well and say velocity check on player, just to make sure that the player is once he's standing still, we don't need to do all of this stuff again. It's again, like I say, it's overkill, it's unnecessary. So let's just double check that that's the case, and this is what's going to happen. Gosh, no, sorry. Bolt can be finicky about making their groups smaller. Might be the way I grab it, but okay. So let's see if my theory works, and if this. So we're going to watch this, and the moment I stop, it should fire off once, and then it should lock itself off. That's interesting. That's not the case. Why is my velocity acting or behaving in a manner that I'm not liking? Might be the error. I assume I'm getting no errors. That's interesting. Okay, so I'm going to remove this and let's just do a vector 3 check. So let's check it against all 3 values and see if that might be what's causing the problem. Or maybe I can do a 0. Let's see. Are you smart enough? Vector 3.0. This might actually work. Let's try that now. Hopefully, I haven't used all my brain power for all the wrong reasons. No, it's still... Oh my gosh. Okay, hold on. Let's try equal and let's see what happens here. I know I'm playing with floats, so I'm taking a chance that it might never actually be completely equal, and therefore that's why the result is not coming back the way it's supposed to. So I'm going to just try the opposite direction and see if equal will at least give me, but not equal should have been the better option. I know, there we go. I don't know why not equal did not work. Okay, so now you'll notice that as I run around and I stop, I'm looking down because that's the last direction I moved. And if we look down here to see what's happening here, the value that's coming through is 1. I'm dividing it by 10, which gives me 0.1, which gets fed into the animator, which in turn gives us this value here, 0.1 minus 0.1, those idle values. That is what I'm doing there. And it takes a lot less effort to do something like this than to go and say, create a, like, the usual way that you see online is you'll have, let me create empty states here. You'll have one for your up, you'll have one for your right, one for your down, one for your left, and then you'll go and say, if I press this key, I'm going right, up, down, right, and left. And those are going to be either booleans, or you're probably going to do a velocity check of some kind, and that can get really, honestly, can just get really tedious. So I'd rather not be doing something like that. I'd rather be doing something that makes a little more sense, and we're using a blend tree, and a blend tree makes sense if you look at the way the animations play through, and you're like, ah, that's what I'm doing. That's what the setup is supposed to be doing. Okay, so now that we've done it in Bolt, we can go ahead and do the exact same thing in code. I'm going to close this because we have the animator. So I'm going to duplicate this and assign this to the C# guy and delete this one. Reposition my character. I know it doesn't like it to be 90, but... And then I'm going to just copy the capsule collider size. So I'm going to say copy component. Go here, right click and say paste component values. Remove the sphere collider because we no longer need it again. And just up the position, I think. Make it 1. So 1. So I'm going to make mine also 1 off the ground, just to be safe, just so that they both look the same size and they all kind of behave the same way. Okay, so it's still got its little rotation. Okay, I'm just going to change this one's color so that we can see the sprite, which one is which. So this one is going to be a little bit blue, or green actually. What color do I want? Let's make it green. That's going to be the C# one, and we need to duplicate the code, so I'm going to just, so that I don't overwrite the existing one like I did in the previous, so I'm going to go and duplicate it and call this one 2D, actually should be top down 2D. And be aware, when you do that, I've copied the name, you're going to get errors all the way through here, because the reason for that is if you open up this code, be aware that the name of the script needs to match the name of the class, the mono behavior class. So over here it says camera controller code TD2D, and this needs to have the same name. So you can either paste it or just type it so that it matches. The moment you do that, all of the errors that you had before are gone. And I went and actually duplicated the camera one. Well done. We don't need the camera one, so I'm going to delete that. That was a serious waste of time. Okay, let's duplicate this again. Okay, duplicate it, give it a new name, TD2D, select that. I'm going to open it up again, and I'm going to rename it at the top here to match the name of the file. And we're going to remove a few things. We do not need the rotation. Remember, that's what we removed from the previous one. We don't need the velocity. We do not need the jump. We do not need the ground check here, because we're just making a top-down game. Animator reference.set float. We'll go and change that shortly. We do not need the jump here either. So I think we are removing anything that we don't particularly need. which means you can go and remove any kind of variables that aren't being used. We should have done the same thing in Bolt. There's quite a few variables that aren't required anymore in that code. Okay, so now that we do that, we're going to go back and quickly just assign the script, and then we'll go and do the actual code that's associated with it. So we're going to remove this one. I'm going to drag this one on here. Remember to assign the rigid body again, and the animator, which is on the sprite, and we can test this out to see if everything works with the exception of the actual animation. There we go. It's working. So let's disable the camera bolt one and turn on the C# camera. Just going to make this 15 as well. And remember, the camera is in the wrong position, so I'm going to select my camera bolt, right click on the transform, go copy, go to the camera here, right click and say paste component values, so that the camera is now matching, the two cameras are in the same location. No point doing the work twice. There we go, they're both moving, the animation's not working, so let's resolve that issue. In a second, we just need to close this. There we go. Okay, back to Visual Studio, and let's just look at what needs to be done. So we have our player input like we need, and that's what we want to do. We need to update that before we update the actual animator. But we need to update the animator based on a few things, based on two new variables that we're going to have. So we're going to go and create a private. Name it now. There we go. Float. We're going to call this one Animator X, like we did in Bolt. Call this one Animator Y, just like we did in Bolt. So we have our X and our Y variables. And we're only going to be, remember, we're only updating these values in here. But we are going to be using our Animator X with a 1. It's going to go like this. Remember, this is X, and now we need to duplicate this line because we need to set two floats this time instead of one. So this one's going to be Y, and this is going to be Y. There we go. So now we are updating our Animator X and our Animator Y like we're doing in Bolt again. But now we're going to go and update these values based on here. So let's just do it right here actually. I'm going to add a new line of code. We might as well just do it at the top where it's easier to keep track of. And we're going to say the following happens. We're going to say Animator. Never know where my X disappears to. Animator. Holy crap, just copy this. Copy Animator X is equal to player input. And then the next one is Animator Y is equal to player input Y. Like we did. Remember, that's what we've been doing up to this point. We've been going do that, and we're good. Oh, I removed my else statement. That's what happened. Okay, and then over here, we're going to do else. And I'm going to do an if this time. So else if, and we're going to do that if statement. If the rb.velocity is equal to vector3.0, actually let's try if it's not equal. Why is my, there we go. Oh, that's why. Oh, equal. Stupid. Okay, so let's try this and see if what the results are. So if rb.velocity that is equal to 0, then in here we're going to do the following. We're going to say rb.velocity is equal to vector3.0. So we're going to zero out the velocity, and then after that we're going to take the animator X, we're going to say is equal to animator X divided by 10. Remember, that's what we did in the previous one, and I'm just going to duplicate this line, change this to Y. Whoa, wow, getting all the wrong keys today. Change this to Y, copy this, and paste it there. So we're dividing those values, and I think that's it, if I remember correctly. And let's just do a debug log here just to make sure that it only fires off one. Stop movement. Oh, this is going to cause so much grief. Okay, so I'm going to do this here. I'm going to do else. We're going to remove this if statement here. So else, so if it's doing that, then do that. Else, do this. But in here, we're going to do another if statement just to cover our bases. I'm going to select these lines and put in here, because the other one was going to cause some seriously interesting results. If, else. And again, we only want to do this. This will fire regardless all the time, so we only want to do that if this here happens. If we have too many brackets here, let's give this a shot and see what happens. Save, save, compile, compiled. Okay, so let's try it. So we should, they both should play animations. There we go. Let's see the console. Let me just collapse that value. Yes, it only fires once when I release the button. And it works. There we go. And that's it. So I hope this has been helpful. I tend to waffle a little and mumble a little bit. Sorry about that, guys. But just notice the simplicity of that. Especially, it just in code, we see it's really, really well. We just created two new variables. We fed them. So we essentially made one new line of code for the animator. We added two new lines over here just to inside of our actual input, and then we just added essentially just two more lines again down here. We don't need this one. We can't even count that as a line of code really. And that's it. So we have now got the little character moving around. And what's nice about doing a 3D version of this is that you can also use NavMesh. There are 2D pathfinding solutions, but I always kind of find like if you're kind of getting into this and you're struggling to kind of figure out AI, using your Unity NavMesh as a starting point is a really good way to get going. But that's it. I hope you enjoyed this. I hope this has helped. Be safe until next week. Cheers, guys.